put this variable dv to represent the duration or factor, so I don't need to put this range. I need to put this range on the following program, so I can change this tolerances easily. And here I said this is 15 because 15 is the best, and 100 I found is not good. In receiving power I checked it, this is better. And in the first pulse check, this is the left time here. You can say I use this 2D. Why is 2D? So I refer to these sketches. The first pulse is here, or the two following edges. And then these following edges. For the first bit is much simple. I just look at these two following edges. 1, 2, 3. If it is 3D, the interval is 3D, that means it's 1 bit. If this is the following edge here, 1, 2, if 2D is 0 bit. So going back to here, the first pulse check here is 2D. This 2D is 820. If this is correct, then this is 0 bit, and then I turn the data into this data to 0, and this 4 bits is of no use. I only use the rest of 12 bit. So the first bit I receive, this I return it to 0 and use the AND function, and then bit here this. So bit here 11. That means I received the 11 bits. And if it's 3D, that is, you can see here, it's 3D. This is 1 bit, and then I will use 1 here and use OR function and input into data 1. And also I clear this fat 0.11. Going to the second bit to 12 bit, and this bit's a little bit complicated. You see, it's just what I mentioned this before. In the following bits, I need to check 0, 1. I need to see the previous bit. So I set for I going from 2 to 13. I is the second bit. Go to 12 bit. I use the following. If first 0, I put it. Actually, it's quite difficult to read this. I need to use fat I is equal to 2 into it. 2 represent number 11. This is because the previous one I received, so I go to 11. The previous 12 bit I received, I checked it, so it is 11. And then fat 0. Fat 0 is the representations. I need to explain this fat 0. First, here is the first 0, and this is a integer. First 0 is 4 bytes. You can see it goes from first 0, 0, 0.0 to 0.03 is the data bit. That is the representation of the key switch, 4 key switch, while from bit number 4 to bit number 11 there is 12 bit to represent each address bit fed. Once the bits are decoded, I will set it to 1, otherwise it's still at the originally 0. So going back to the program, at the first pulse I decoded the first pulse. I will clear it. I will clear the fat 0. Sorry, I need to clarify. This is used to signify the corresponding bit if it is 0 or 1 after decoded. If it's 0, it keep on this flag is 0. If it decoded is bit 1, it will turn this flag to 1 for later uses. So here on the first pulse check, if this is 0, I will keep this clear 0. If this decode is 1 bit, is a 1 bit, I will set. And here go to 2 to 12 pulse check, and going back to here, I first put number 2. That is the second bit, the 11 bit, and 2, this will be 11. 11 shift this 1 to 11, and flag 0, that is the flag I just mentioned, and check to see if this bit 11 bit is, if it is 1, then this is 0. No, if it is 0, this will be 1. This 11 is the previous bit. So if this is, so the previous, this is the previous bit. Checking the previous bit. Why is this previous bit is 2? This is 11. Since we go from 0 to 11, so 11 is the almost is the most significant bits for the address bit. So the previous bit, if it's 0, then this 2, this is a 0 bit. Then we will processing to check. That is the previous is 0, is 0. And if it's 3D, this interval is 3D and fit the statement, then this will be a 0 bit. Otherwise, it will 4D, it will 1 bit. This 2 statement is for previous bit, 0. And the next, if it's not, the previous bit is 1, previous bit is 1, then if this is 2D, this is 0 bit. If it's 3D, it's 1 bit. And so as before, is if it's 0 bit, I turn this number 10, 0.10 flat to 0, keep it 0. Otherwise, I will set this, because it's 1 bit, I will set it to 1. So after doing this bit, and here is a little bit complicated. I put this 2 into here. 12 minus 2 is 10. Here 13 minus 2 is 11. 11 is the previous bit. Now is go to existing bit, and I right shift this 1 to 10 position, and it will go to this like this. It will bits like this. 1 is in this position. And what I need to turn this bit to another bit, so I can use AND function to existing data 1 value and don't affect other bits, and only change the 12 minus 2, the 10th bit. I need to do some bitwise operation so that this bit will turn to this bit. I don't care the uppermost 4 unused bits. I want to turn to 1 to 0 and the rest into 1. How can I get this? I use exclusive OR, and exclusive this one to all 1 value, then I will get this data. So here I use this after the AND. It will not affect the rest of bits, and only change the corresponding bits, that is the existing bit, to 0. If the existing bit is 1, here is 1, then it's simpler. And if this existing bit is 0, and go to shift by 10, this 2, then 12 minus 2, 10, shift 10, the 1 bit go to the 10th position, and I just do the OR function with the existing bit, existing data, and store it to existing data, and also turning the fat number 10 to 1, set this 1. And else is, if this is not, the previous bit is not 0, if it's 1, and do the same again, just some changes. This will complete all the rest of bits, 12 bits. And here is no use, I just wait more for other use. And then this program is to mask the data and bits, 4 bits, mask out the 4 bits. The most 4 bits is no use, and the lowest 4 bits at this position is not used, because this 4 bits is the key switch. I just want to check the address bits here, this 2 bytes, muscle, and this is the predefined address bit. If it's correct, then I set this fed decode into 1, and then I muscle all the rest for the original, and I want to get the data bit for the key switch, the 4 bits, so I use and this 0. This data to 3 is for key switch, this data to is for address bit. After doing this, I reset the data 1 and data 2 to 0. Since data 2 I don't need anymore, it was decoded. I just use this flag to represent it decoded. This I only and I do need is data 3, the key switch, and then this turn into 1, fed 1 1. This is the either the receive pulse, if necessary decode, resets the fed pulse variable to 0 for the next inputting pulses. So I reset this. I set this to 1 and turn on the external interrupts again. In case I need to press another key switch, so I need to turn it on again for receiving the next power train and delay 100 milliseconds. I wait for a short time to prevent the LED flash too fast or scripted too fast. Then I go back to loop again. This subroutine was done, finished, and I go to main loops again. Here it turn the decoded data to switch bit 0 1 2 3. Since as explained before, the decoded bit is like this for the data bit. This. What I need to do is turn this to the represent to 1. That's the first key received. It's a little bit further. Sorry. Turn this into 1. This represents the key switch number 1 press. This represents 2, 3, 4. I use switch function. Then after this data variable, I put it into here. For this statement, you can refer to my pooling function codes. I explain this detail for this, and I'm no longer to describe here. This is belong to the hardware main function, and this is the main demo board key switch. This portion is the key switch on the emitter board. There's no else news, and for some other area you can refer to the pooling method. And that's all for the talks of this infrared remote control, and it's a little bit complicated for the interrupt methods than the pooling methods. And thank you for your watching. If you like the video, please thumbs up and also subscribe this. Thank you for your watching.